Hi again. Well, in this video, we're going to continue with confidence intervals, but switch over to proportions. So remember in sampling distributions before, we used the example of blood type. And in the US population, about 37% have type O blood. So I want to go to the stat key sampling distribution applet again, but this time the one for the proportion. We're going to need to edit our proportion to change it to 0.37 for 37%. And then this time I want to use the sample size of 100. And we're going to generate one random sample of 100 people. And we did have a standard error of that. I'm using our sampling distribution from before. We did remember the graphs with the we had four different sample sizes. We did use 100 and we got a standard error of 0.048. So that's the one we're going to use for our standard error. Remember, we're still pretending that we know the population proportion, the true population parameter, just so we can understand confidence intervals, but very soon we're going to take that away. Okay, so let me go over to stat key. And this is the sampling distribution for a proportion. I'm not worried about any particular data set here because we're going to edit the proportion. So click on Edit Proportion and type in 0.37. Okay. And then I also need to edit the sample size. 200 seems to be the default for that one. So I'm going to change that to 100. Okay, so this will match one of the sampling distributions that we did before. And again, like the most recent couple videos, I'm only going to take one sample, okay? So I like how on the right here it does have our original proportion, so that's the population. Instead of a histogram, because this is categorical, it just shows us the true proportion, or P. Okay, now in our sample, we got 34 out of 100, or 0.34, okay? So let me go write that down on the notes. It says generate, get rid of the mouse, generate one sample of n equals 100 people and write down p hat, okay? So our p hat equals, whoops, was it 0.34? Yeah, I can't do too many things at the same time. Equals 34 out of 100, or 0.34. Okay. And then, just like we did before, using the formula above in the notes a few pages ago, calculate the 95% confidence interval and does it contain the true proportion. Okay, so remember our formula. I'm going to write it out here, is p hat plus or minus 2 times the standard error, or 2 standard errors. Okay, and we did our whole sampling distribution for n equals 100, so that was all the random samples of n equals 100, and that told us our sample-to-sample variation was 0.048. Okay, so I'm going to go ahead and calculate that. I'm going to put in 0.34 plus or minus 2, and I like the parentheses, 0.048. And I'm going to calculate that margin of error, which is the 2 times the standard error. 2 times 0.048 is 0.096. Okay, then just like last time, I'm going to do the minus and the plus. So 0.34 minus 0.096 and 0.34 plus 0.096. .34 minus 0.096 is 0.244. 0.34 plus 0.096 is 0.436. Okay, it's pretty close. This is 0.9. Oh, I guess it's 9%. It's quite a bit. I was thinking it was like almost 1%, but it's almost 10%. Okay, so let's go ahead and write this together. You could write it two ways, 0.244, comma, 0.436. Or you could change it to percentage and write 24.4% to 43.6%. Okay. So now let's look and see if this contained our true proportion, which was 0.37. I was like, wait, what was it? 0.37 is our true proportion. So yes, it does contain this. So this interval does contain the true proportion 0.37. Okay, so I thought we should play around like we did before with getting 100 confidence levels. If you feel like you already got that, you can skip it, but I'm just going to do it real quick. I'll do it not as many as I did the other one, but on the right here, I'm going to click on the confidence interval tab, and there's our one sample proportion of 0.34. You can see it captures, there's P down at the bottom, so you can see it captures our true parameter P. And I'm going to go up to 10. Still capturing the true proportion. Okay, we got it, 10 out of 10, 100%. Now I'll go by tens and see. Wow, I'm up to 50 with 100% coverage, 70. Okay, missed one there, 90, 100. Okay, 98% coverage, so that's in the realm of 95% confidence, right? We're missing 2% of the time. Let me just reset. This has the same function of reset and generate 100. This time we missed the true proportion, 3 out of 100. This time we missed 2 out of 100. Wow, okay, this is the worst one we've seen, 91% coverage. So we actually missed it 9 times. Still an A, right? So 95% is pretty good. And again, in the long run, we should average 95% confidence. But remember, we're only going to take one in general. We don't know if we've got a red one or a green one, but that's why we don't say we're 100% sure. We have 95% confidence. Okay, so let me go back to the notes then. And we have a similar thing here, so I won't need to write so much on here, but I'll just put, here's our P at the bottom. This is our true proportion. P equal 0.37. And then let's see, this one that I did for the notes had 96% coverage, so 4 of them are missing. And let's see if I can find them. There's 3. Is this one? It's hard to tell if they're on the edge. I think it's one of these two. This one looks a little further to me. Anyways, 4 of them missed. So on average, or in the long run, we expect to capture the true proportion (95% of the time. Since we only do it once, that's why we say we're 95% confident that the true proportion or the true parameter is between blank and blank. Okay, so in the next video, we'll talk a little bit more about the wording of our conclusion for confidence intervals or interpretation. Okay, see you there.